Hi. In today's installment of Spring Tips, we're going to look at uh, basics for Spring, just absolute basics. So Spring 101, if you will. We're going to build an absolute basic, simple Spring application using Spring Boot. And before we can do that, we need to have a sample application with which to work. And we're going to do so. We're going to create that application here in the Spring Tool Suite 4. The Spring Tool Suite 4 is, of course, just a number of different plugins that work on top of either existing Eclipse distributions or as a separate thing that you can download with its own Eclipse distribution. It's all open source, so you can download a complete Spring Tool Suite 4 distribution with Eclipse and everything else all in one bundle. That's what I would recommend. That's just super simple. You just download the binary for your relevant operating system, Linux, Mac, or Windows, and you're off to the races, right? So then you build a new application. I'm going to build a new application here by going to File, New, Spring Starter Project. It's going to give me a wizard, and this wizard is just an easy way to configure your new application. I'm going to build a new application called Reservation Service. I'll hit Next. It's going to give me a bunch of different checkboxes or things that I could add to my application if I click on any of these different drop-downs. For our purposes, I'm pretty happy. I've already got reactive web support, DevTools, Actuator, Reactive MongoDB. Those are my frequently used ones, for example. So I hit Next, and that'll give me a URL. Now, keep in mind, this IDE is just a fancy front end for the start.spring.io Spring initializer. And if you wanted to, you could, in theory, go to that initializer, paste this URL into a browser or a console, and you'd be given a zip file. You download a zip file, and then you can unzip it and then import the resulting Maven project into your IDE. But why? Why bother with all that extra work when you could just go to the IDE and choose File, New, Starter, and just hit go? So that's what I've done here. I've hit Finish, and that'll give me a new project, and then I'm going to open up that project in my IDE. I've got it here, and I'm going to choose File, New. I've already chosen all that. I've got a new application. It's a Spring application, okay? And the Spring application, ultimately, Spring at the end of the day, is just a big bag of objects. It's just a big bag of objects that you describe, that you contribute, that you provide, you define. These objects represent your business logic, and the goal is for Spring to do as much as possible for you. Without invading upon your code, in disturbing your business logic. And so we have this thing called dependency injection. The idea behind dependency injection is very simple. Let's suppose I wanted to build a API, an HTTP API that supported access to your data, which is itself stored in a database, which you facilitate access to through a repository. Okay, these are different logical layers in the application. You've got the web tier, you've got the repository, which represents the data access logic. It's just another object, and then the repository in turn depends upon and manages a reference to your database, the actual connection to your database. Right? You've got three different objects: the REST API, depending on the repository, depending on the database. If you tell Spring about these objects, then you can centralize the definition of these objects. You can keep them in one place, and if you want to change them, you just change them in that one place, and then all the code in the application that depends on those objects can be updated accordingly. Similarly, you don't have to do all the work, right? So let's say you wanted to build an HTTP service. Well, what's involved in building an HTTP service? Well, you need a web server. So there's a good few days of work just learning all about web servers and standing it up and configuring routing and then connecting that routing to your object somewhere in your JVM code. And then once you've done that, now what? Well, now you need to get a pointer to that repository, and that in turn needs to manage a reference to the database. Who creates the database? You could certainly do that, right? But why not let Spring do that for you? Let Spring Boot in particular do that for you. So there's two things going on here. One is you can define objects and then teach them how to wire themselves together using Spring. And if you want more help, if you want, for example, the web server to be provided, if you want, for example, the database to automatically be created, if you want these kinds of things, then you can go to Spring Boot. Okay, but it all starts with Spring. It all starts with understanding how things relate to each other. So let's say I wanted to build a simple REST API. Okay, so let's say I have an application that manages access to data through MongoDB. Okay, so I'm going to say class reservation REST controller. And this is going to be an object that's going to manage access to my data in MongoDB. So I say private final, and what do I need? I guess I could start off with a very low level. I need a service of some sort, or a repository at the very least. I could say class reservation repository, and then this would, I guess, at some point need access to a Mongo database, wouldn't it? Right. So Mongo database. There we are, DB, and I'm gonna say Alt Command S, and that'll S as in Sam, and then I'll override. I'm going to generate a constructor from my fields. There we are. Okay, so I've created an object that has a dependency, which I've expressed here through the constructor, on that Mongo database. We don't know where that comes from, and my REST controller, in turn, private, private final reservation repository. Like so, repository. Same trick, I'm going to do Alt Command S. I'll generate the constructor. Voila. All right, not bad. So I've got that. How do these things get wired together? Well, one way to do that, one way to get these things wired together is to be very explicit. You can use Java configuration. So I can say class reservation configuration, okay? And here, it's just an object that Spring knows about, that because I've annotated it with a marker annotation, a so-called stereotype annotation called @configuration. @configuration ultimately is annotated with @component, and we'll talk about @component again, but this is the annotation that tells Spring to sweep up any class that's been annotated with it, or or annotated with an annotation that is itself transitively annotated with it. It'll sweep up that object for managing, right? It'll manage it for us. So it's going to see this configuration annotation. It's going to see that it's @component. @component is enough for Spring to manage it, but @configuration goes one step further. It tells Spring that there are methods in this object, this class, that in turn produce object instances for you. We call those, in the Spring world, we call those resulting objects beans. An object that's been managed by Spring is a bean. And so you create a method that's annotated with @bean. So let's say reservation REST controller. Okay, reservation REST controller. And there's my controller right there. Very simple, right? And I want that controller to depend on my reservation repository. So reservation repository, and we say return new reservation repository. Okay, and that depends on a data source. Well, my goodness, bean, Mongo database, right? And for now, I guess we can just return null. I don't know how to create a Mongo database offhand, but let's just return null for now. We know that needs to get sorted out eventually, right? But just not now, okay? So I'm going to inject, I'm going to tell Spring to inject, or to satisfy the requirement for this collaborating object, like so. I'm going to tell it to provide it in the prototype for this method, okay? And finally, my REST controller here, similarly, it needs a pointer to the repository. So I'm going to say new reservation REST controller. I'll provide a pointer to the repository, like so, reservation repository, RR. All right, look at that. So there's my three objects that are related to each other. One depends on the other. The database, we haven't, that's a big old to-do right there. We've got the REST controller, but of course we don't have a web server yet. So if you look at this configuration, this is nice, but we don't really have a, how do we, what does it mean for this REST controller to be an API that gets exposed to the internet? I could have annotations like this. I could say @get mapping / reservations, and have an endpoint here that returns, all the data. So return this .rr .repository, and what do I want to support? Well, I want to support a method called find all. I want to find all the data reactively. Okay, so we don't know how this is going to work, but we know we want to support it. Okay, so now a couple things to break down here. First of all, A flux is a kind of like a collection. It's a type that will manage immediate access to a stream of data that will be delivered to us asynchronously. Not right now, but perhaps later. Also, I want to manage instances of type reservation. This is a whole service designed to support managing entities of type reservation. So let's go ahead and define that type. Okay, let's go here and say create class reservation. It's going to be a brand new object. It's going to have what? It's going to have a field, private string ID. This will be the ID that will be stored in the MongoDB document, and then private string reservation name. So there we go. There's my basic entity. Okay. This is obviously Java, so I need some getters and some setters and so on. So I'm going to say Command Alt S, and I'll generate some getters and setters for my fields there. Select all. Very good. Generate. Alt Command S for the constructors, right? I want that in the toString. Okay. And I want the constructors using those fields as well. And then we want one more constructor with no fields. So deselect all, hit generate, and there we go. There's my my basic arrangement, my basic object. Okay, that's all done for me now. And here I want to say find all, right? We don't know how to get that result yet, but we know that's what we want to do. Okay, so there we go. This is my HTTP endpoint. I'm telling Spring, hey, I want you to take this method and invoke it whenever somebody makes an HTTP GET request to /reservations on our web server, which we haven't defined yet. We don't know where it's going to come from, but we know that we want it, right? And we've told Spring, look, I have a constructor, provide a pointer, a reference to the reservation repository. That's this thing down here. And the definitions live down here, but the construction logic for all these things lives in this configuration class. Well, turns out that's a little bit of a disconnect there. In this case, it makes sense. Obviously, the Mongo database, I have to construct the instance because there's no way to do otherwise. But in this case, why not just have the definition of the objects and their wiring live on the component class itself, live on the object code itself? So I'm going to annotate this with another stereotype annotation, another marker annotation called @REST-controller, and it follows the same rules as that configuration and as that component. Because it's in this package, it's going to be discovered by the component scan when the application starts up. Similarly, I've got a repository. I could say this is a repository, like so, and the repository is itself meta-annotated with @component. So I've got all these things, I've got repository, I've got @REST-controller, @configuration, and these are my different objects, and Spring is going to look at these marker annotations, and it's going to sweep up these objects and manage them for us. And the dependencies, one upon the other, is implied by the types and the constructors and so on. So this is very, very, I think a very clean approach. Now, the only thing here is this database. Well, I do need to define that at some point. I need to have that definition somewhere. But we're using Spring Boot. And so Spring Boot can help us the rest of the way. It can help us go from, having these objects that have these HTTP endpoints, which is already pretty convenient. And we can ignore now, for example, what it means to wire up our object to our web server. Now we can, thanks to Spring Boot, we can ignore even more. We can actually say, for example, to Spring Boot, look, you've got this file, pom.xml. This is your build file. And in there, you've got Spring Boot starter data MongoDB reactive. That means that by default, Spring Boot is going to try and create a connection to the local host running instance of MongoDB. And so I can drop that bean. It'll just provide a default bean for us. And so all the code that needs it will inject it. That means that I could actually run this code if I wanted to and it would inject it. But again, looking at this code, this is actually, let's suppose I built this code. Let's suppose I did that. I could do that, but talking to the database like this is very low level. So instead, another thing that makes Spring so useful is that we have these abstractions. These are very low level abstractions that make working with tedious infrastructure, things like databases and message queues and so on, easier to work with. It boils down all the sort of boilerplate code. It reduces that down to the barest minimum essence of the thing that you're trying to do. So instead of using MongoDB directly, instead of doing that directly, I'm going to use a reactive Mongo template. Okay, and the reactive Mongo template is just a convenience client that you can use to talk to MongoDB. And that will be the thing that I introduce that I inject in my constructor, like so. Once I've done that, I've got a reference to that, and I can use that to good effect. I can actually say now to Mongo, look, please go to the template, go to the database for me, and find all documents and match them or map them to my reservation class. Okay. And so it's in order for it to do that, it's going to need some information on this reservation. It's going to need to know how to map the ID. This is the ID field, right? The document ID. And it'll need to know that this is a document, like so. All right, so this is my document. Now, once I've done that, I think that's pretty straightforward, don't you? That actually works. But you know what? This kind of work, easy though it is still a little low level. Consider that I still have to create a CRUD, CRUD. I have to support all the kind of CRUD lifecycle methods. I have to create, read, update, delete. I have to be able to support custom queries and all that kind of stuff. So we can go one step further. Spring Boot has automatically auto-configured for us Spring Data. Spring Data is an umbrella project that provides the ability to, based on an interface definition, automatically provide a definition of the object that satisfies that definition. So reservation repository extends Reactive Mongo repository. And this is going to be a repository that manages access to a entity, a document in this case, of type reservation. So command 1, import that. Right? Look at that. Not bad. So it already has methods. If you look at this Reactive Mongo repository, it already provides methods for inserting based on a collection, inserting based on a reactive publisher. We can find all, given a example that we can look at. Find all based on more examples, and a sorting condition. It supports reactive sorting repository, which says find all given a sort condition. Reactive CRUD repository supports saving all, finding by ID given a publisher, checking if it exists, and then finding all, which is actually the thing that we defined or started to define earlier. So all these different kinds of common lifecycle methods are implied in this interface. And that's all we need to do. Spring Data will take this interface and provide an object that we can then inject. This is right here, right? I can inject this by type. If I put a breakpoint here on line 31 at runtime, I'll see that I don't actually have this interface. Obviously, you can't just inject there's no such thing as a runtime instance of an interface. You have a type that implements an interface. So I will have a pointer to a reference to an object that implements reservation repository. That's in my Spring Data code. So now I have a very simple API that depends upon the repository, and the repository is down to just an interface. I can create custom finder methods as well. I can say I want to find all instances of this reservation by the reservation name field. So that like that. And that's it. That'll actually get implemented. Based on convention, Spring Data is going to say, I'm going to create a BSON query that looks at all the documents in MongoDB and finds the MongoDB documents that have the attribute reservation name whose value is equal to the value that we provide here in the RN parameter. And that just gets done for us. We don't have to implement that either. It's just done for us automatically. So that's all Spring Boot. Now, of course, I have got this REST controller. Spring Boot is automatically going to make sure that that's a working REST controller. This is one way to create a REST controller, by the way. There's two different ways in Spring. You can actually use this style, which is very nice, or you can use the new functional reactive style. So let's try that. Router function, server response, routes, return router functions dot route. I'm going to provide a request predicate dot get / reservations. And this thing that is required over here is a object of type handler function. So I could provide a lambda there, but what I like to do is to use Java 8 method references. So I'm going to say class reservation handler. Okay. And this is just going to be a regular old Spring Bean, nothing special about it, just an object that I want Spring to manage for me. And I'm going to say, I'm going to say I want to it's going to implement handler response or handler, right? It's going to implement the second type that's required here for the route method. Yep, there we go. And the type that's required, the thing that's required is a handler function. So I'm going to create a handler function. I'm going to implement handler function of type server response, like so. Implements handler function of type server response. Okay. So there's my custom handler, bean. Import that, import this, import that, and we're going to have to implement those methods. So I'll say command 1, and you can see that the method that it's expecting is handle given a server request. And actually, I don't even need to implement this. We're going to use a method reference. So I'll get rid of that. And there we go. There's my handler. And I'll say that this is the handler that provides by ID. Okay, so reservations ID. And this handler, in order to do its work, will require a pointer to the reservation repository. So reservation repository, like so. And Alt Command S, generate the constructor. And there you go. So there you go. There's my custom handler method. I'm going to say that I want to inject that collaborating object here. I'll provide a collaborating reference here to the handler, and I'll use a method reference in Java 8, handler by ID. There we go. There's my custom method. And that's a very straightforward piece of code. Obviously, we can abbreviate it a little bit. Let's use command 1 again to convert to a static import. Okay, very nice. Use that again, static import. Very good. So that's actually a separate way of providing the REST endpoint. Let's actually implement that now. Let's say server response. Well, first of all, we're going to say request.path variable is equal to ID string ID equals. And what I want to do is I want to look up the record by its ID. So I'll say this.repository dot find by ID, passing in the ID. And this will give me a publisher of reservation, mono of reservation. That's actually another publisher. Mono and Flux are both publishers by ID results. Okay. And now I'm going to send a response back to the client. So server response .ok.body is by ID results, sending in reservation .class. All right, there's our whole piece of code. Clean that up a little bit here. There we go. So that is the whole handler, the REST controller, the repository. All of that is here. Very simple application. Let's go ahead and run this. Okay, so let's go ahead and run this application. And you can see I've got here the boot dashboard. So the dashboard is running. It's already in the background. It's there on the local thing. I'm going to go ahead and hit click. I'm going to go ahead and click run. That'll start up the application. And as the application spins up, you can see that it's on the everything's fine on the console there. We don't have any data. I didn't actually write any data to the database here. So maybe I should create some code to write some sample data to the database. So I'll create an initializer. It's going to implement the application runner callback interface. The application runner callback interface is a Spring Boot and a type rather. And I'm going to import that and add the unimplemented methods. And then when the application starts up, I'm going to inject the reservation repository here. We'll see that like so, repo, and we're going to just provide that into the constructor as before. And you can see on the bottom here, as I'm making changes in my code, Spring is restarting the app, just automatically trying to reload the changed code. Of course, sometimes it's failing, so we're getting these, unsightly errors there. But that's okay. That's, it's not compiled code, so sometimes it doesn't work. When it does compile, it runs and it works just fine. So here, I'm going to write some data. I'm going to say flux.just A, B, C. And I'm going to map each name to a new reservation. Null for the ID, name, and then flat map R. I'm going to save it to this.repo.save R, and then that results in an object that'll actually save data to database. Actually, you know what? Better yet, I'll just do subscribe. There we are, subscribe. Okay. So there's my whole thing. That's just going to write data to the database. You know what? Actually, better yet, I'll leave it as flat map, and I'll say dot subscribe R system. Okay. Reservation to string. There we go. So there's my application. It started up immediately. There's the results on the console. So that's working, right? We can see that our simple bit of code is working. When I start the application up, an interesting thing happens. So let's go ahead and close all the other tabs. Get that back. As I start it up, suddenly my application becomes green in certain places. So you see, the Spring Tool Suite 4 focuses not on development time validation, because really Spring is just Java, right? You don't need anything there's nothing more than the compiler and you know, your understanding of the APIs to really guide you here, right? The runtime, the sort of resulting runtime behavior of the application is determined entirely by Spring. So there's no like static analysis that we can do that would be without re-implementing Spring for the IDE. There's no point in doing that either. So instead, Spring gives off information about its running application, and that information feeds back into the IDE. So you can see that here as this sort of little green highlights for different types and different things in the application. You can see, for example, if you mouse over at component, it shows me that this is a bean that is called initializer. The ID of the bean is called initializer. It's running in this process and inside this scope. Inside this class, based on this configuration class. We can see that it's a bean that lives inside of the reservation repository type. You know that we can see that this dependency up here with the arrow is injected into the initializer. The bean itself is called reservation repository, but it lives in this type. This is an interesting thing here. These arrows are very interesting in Spring Tool Suite 4. It's giving us the dependency graph. It says here, my routes bean depends on the handler, and that's what that left arrow means. That means that the thing on which this watermark sits depends on the thing in the watermark. The initializer depends on the reservation repository. Going the other way, we can see, and here's another example, by the way, my router function and my reservation repository both depend my reservation handler depends on the reservation repository, but my router function depends on the reservation handler. So this is the things that depend on this object, and this is the thing that is injected into this object because it depends on them. Okay, so both directions. Right means it depends on my reservation handler. Left means my reservation handler depends on it. Okay. We also have feedback here at runtime as to the URL of these of this mapping. So I can mouse over this. It says, yeah, if I were to go to localhost 8080/reservations right now, I would be able to see this endpoint. And surely as can be, I do see that endpoint, right? I can click on that endpoint. I can see all the data there. I've written more than a few records over the last several days into this endpoint. So we know that that's working, okay? Now, I've seen these endpoints. I've seen the navigation here. I've got a couple of different endpoints, don't I? I've got the endpoint that's defined here by this handler. The logic for this is in the handler. If I click on that, I can see that that endpoint is providing business logic for me. If I make it public, we can also see that it says that this is an endpoint that it actually shows me the mapping annotation if I make it public as well. So that's very convenient. And I get the ability to see what this endpoint is, what URI this endpoint lives at what URI this endpoint is mounted. Basically, it's mounted at /reservations/ID. It response stage should be get, and that's nice because my handler very well might live in a separate code page altogether. For example, I could Alt Command T and just move this to a new type file, right? A new file. When I do that, you know, everything is, semantically and structurally, it's all the same exactly, but my request mapping routing logic is nowhere to be found. It's in a separate code page altogether. So it's nice that I don't have to switch back and forth between the two different code pages to see that this is mounted at /reservations/ID. I have the ability to navigate very easily. I can say Command 6, and if I say, for example, at command or at the at symbol, at component, it shows me everything that is annotated with at component and everything that is meta annotated with transitively with that component. So, for example, reservation handler, reservation rest controller, which is itself annotated with at rest controller, which is itself annotated with at controller, which is itself annotated with at component. Reservation service application is annotated with Spring Boot application, which is annotated with Spring Boot configuration, which is annotated with configuration, which is annotated with a component. So you can see this like really interesting sort of navigability here, and I can click on this, and it'll take me to the code page for that endpoint. If I do Command 6 again and do /, it shows me all the URLs that are available in this application, right? And lets me click on them, and I can see them in action. So I have this really nice navigability in the application itself. And that's all based on this sort of runtime awareness that the Spring Tool Suite 4 has for me. Okay. Now, I like my application. It's certainly a simple application. That said, I want to be able to run this in production. And I'm running at my local machine. You see how easy it is to start and stop and do all these kinds of things. But what I want to do is I want to actually deploy this to Cloud Foundry. Now, Cloud Foundry is a platform as a service. It's open source. I'm going to connect to Pivotal Web Services, which is a multi-tenant hosted instance of Cloud Foundry running on Amazon's East region by default. And I'm going to deploy this application to it, and I'm going to just be able to see what it's doing from there. So I've already got a Cloud Foundry target. All you have to do is you click on plus sign, click on Cloud Foundry target, fill out the form, email, password, the things that you care about for your platform, for your Cloud Foundry instance once you've signed up for an account. And I want to deploy the application. Now, remember what it's do. Remember the defaults. Command Shift R will show me the prop resources. I'm going to open up my property file. I have no configuration here. I didn't say spring.mongo anything really, right? I haven't specified Mongo anything. So I haven't specified logging. I can specify all sorts of things. I can specify server.port, right? Server.port. Server.port equals 8010, for example. If I hit save, that'll restart the application, and the application is now spun up on port 8010, right? So I can do all sorts of things with this property file, and you can see that that Spring Tool Suite 4 is really smart. It shows me different configuration values that I can use to change the built-in application. That said, I haven't specified a MongoDB URL, and I don't want to. In my local machine in development, it's working just fine. I don't need to specify a URL. But when I connect this to Cloud Foundry, that the information as to how it should connect to MongoDB, that'll be buried in the environment variables in the running process in the platform. And those environment variables get turned into properties that are visible to my Spring Boot application when they're running in Cloud Foundry. So what I need to do is I need to tell Spring, hey, this is some configuration that is only going to be available when you're running in Cloud Foundry. Otherwise, just use the default configuration. And that configuration is going to be, I'm going to separate it out. I'm going to tease it away from the rest of the code by using a profile. A profile is just a tag. It's a label. And I can do this for objects and for configuration. I could, for example, go here and say this is a bean, an object that lives under the demo profile, right? So I say add profile, and Spring will automatically make this bean non-exist. So if I restart the application right now, you can see that it restarted right now. It just restarted automatically because I've got the dev tools. No logging on the console, right? Nothing there. That's because I haven't explicitly activated this profile, and because I did not do that, this bean effectively does not exist. Why would you want such a thing? Well, again, imagine you're doing the kind of thing I'm doing. I'm going to take a development environment artifact and promote it to a production environment. I don't want my local host username and password, being used to try and talk to the production database. And similarly, I don't want my production database credentials buried in the code. So I might want to have a separate set of configuration that draws its configuration from an external source. Okay, so I can do that for objects, and I can also do that for this config file that I showed you, the properties file called application.properties. So I'm going to do that. I'm going to go to source main resources. I'll create a new file called application-cloud.properties. And I'm going to give it a very specific configuration here. I'm going to say cat desktop application cloud.properties. I'm going to copy that into the clipboard and paste. So Spring data MongoDB URI equals, and then this property that references a MongoDB instance that I've given a logical name called my MongoDB that's running in the platform. That's only going to be accessible. That property file will only be active when the profile for cloud is active. And in order for that to be active, we need to create a Cloud Foundry manifest. So I'm going to do that here. Here we go. New manifest.yaml. Paste all that in. All right, so I've got an environment variable that's going to tell Spring. It's going to tell Cloud Foundry just let me go ahead and create the MongoDB instance. And it's going to say go ahead and act. I'm going to use an environment variable here. Spring profiles active. Spring Boot automatically normalizes this. So Spring Boot will turn it into a lowercase spring.profiles.active, all lowercase, and the value will be equal to cloud. So what I'm telling Cloud Foundry is I'm saying go ahead and deploy my application as go Spring Go, or just go Spring. Tell it to set up these environment variables for the running application so that my application behaves a little differently, so that the profile called cloud is active, and thus so that it'll draw this property file in addition to the existing application of properties. It'll draw this into the environment and use that to inform where to find the MongoDB instance. And then finally, I've told it to bind the already provisioned MongoDB instance to make that instance visible to my running application so that I can connect to it. It'll put the connection credentials, all that kind of stuff in the environment, and I'm going to use that to connect to it. That's what that property is telling MongoDB to do. Okay, so that's there. Now this is, I'm using the Spring Tool Suite 4. There's some really nice configuration support here. I can customize everything I want about the application using this tooling, but I already have one, so it's fine. One thing that's kind of nice is if I didn't know the name of the service, and with that in place, I can now hit Control Space, and it'll show me all the different connectable backing services, including my MongoDB, for example. Okay. With that in place, I've got Cloud Foundry here. I can take my application, just drag it onto Cloud Foundry, right? And it's going to say, do you want to use this manifest? I'll say, absolutely. I want to enable the JMX SSH tunnel. That could be useful for debugging later. And I hit go. So there we are. There's the application. It's started up. You can see the output as it's showing up in the server itself in Cloud Foundry, right? Here's the application. If I go back to my application code here, for example, I can see not only the local host version of the endpoint, but also now the URL for the application running in Cloud Foundry, http go spring cfapps.io, etc. And it shows me the data there. Isn't that cool? I get now instant feedback from both the local and my cloud environment. I can do things like debugging and all sorts of things. I can administer a lot of the different running applications from the boot dashboard. You get all this for free, right? You get this all just this nice in-ID experience. I can write software, test it, debug it. I can connect to the cloud platform, get it up and running, see how it's looking, and so on. Spring Tool Suite 4, it's very compelling because it gives me a one-stop shop where I can create a new project. I can write code using a world-class Java editor and a debugger and so on. I get smart insight in auto-completion for things like Java and for things like my property files and my Cloud Foundry manifests. I get insight about the running application, which is the only real accurate information, right? There's no false positives here. You're getting feedback about the running application and nothing less. It doesn't show you, it doesn't try and second guess the meta model that Spring has already built up for its running object graph. It just looks at that and directly based on the running application itself. We can see that navigability is key, right? So if I do / it shows me now not just my local host endpoints, but also my Cloud Foundry endpoints, right? The ones that are deployed in Cloud Foundry as well. So I have all that just by doing / at, at is really your key here. It'll show you all the sort of interesting things that you could do in the application. So again, just lots of really interesting things that are discoverable, I would say. I think that's like one of the really compelling features here is that, anybody can build a competent Java IDE at this point. And there's a number of different tools out there that are for that. But when it comes to building enterprise-grade applications that are connected to production, they're oriented for production, that are large enough that it becomes sort of unwieldy, having the ability to navigate quickly from one thing to another to see what depends on the other, how things interact, that I think is a differentiator. So, my friends, we've built a very simple application. We've built an application that has a reactive web endpoint and some reactive data access. We used the dev tools to support live reloading and to support insight into the application. We've also used the actuator. Actuator is a set of endpoints that are added to the application automatically for us, and that actuator information is visible in Cloud Foundry, and that feeds back into the insight that you see here. That's why these URLs reflect what's happening in Cloud Foundry, is because of that actuator inside. Cloud Foundry itself, if you go to Cloud Foundry's Apps Manager, it'll also show you information being fed off of, sort of drained off of the actuator endpoints in the application itself. It'll surface that in a single pane of glass, that ever important single pane of glass or dashboard experience in the Cloud Foundry Apps Manager. So you get a lot of value out of that. And of course, we're building a reactive web application. We have data access. What we didn't write is almost as important as what we got, right? What we didn't write is any code, nor did we have to care about anything related to deploying or managing a server, let alone a reactive Netty-based server. Right? This is Netty, starting on port 8080, so it's blazing fast and asynchronous and efficient. We didn't worry about connecting to MongoDB. We didn't worry about doing anything really. We just wrote the code that speaks to our business requirement, and we wrote code that is testable. So of course I haven't really touched on testing in this video, but all this code is written using constructor injection, which means I can provide the collaborating objects using a mock if I want to, and I can test just the initializer, for example, or just the reservation rest controller in isolation. So you get all that by writing clean object-oriented code. It is very easy to extract things, to refactor things in the IDE. I used Alt-Command-T and Alt-Command-S quite a bit to do refactorings and extractions and that kind of thing. And the result is I can prototype very quickly, and I can make mistakes. And then if I get to a point where I feel like things are stable, I can extract them out into separate types. And the result, I think, speaks for itself. Thanks very much for watching, and we'll see you next time.